organized by IEEE Kerala Section, the Institute of Engineers, Kerala State Center, Computer Society of India, Trivandrum Chapter, Project Management Institute, Kerala Chapter, Internet Society, Trivandrum Chapter, Okka Maulari Foundation Trust, Trivandrum, Life Member Affinity Group, IEEE Kerala Session, IEEE Engineering in Medicine and Biology Society, Kerala Chapter, Institute of Electronics and Telecommunication Engineering. Today, on this 92nd talk, we are extremely delighted to have with us Dr. Uday Shankar S. Nair, Associate Professor, Atmospheric and Earth Science University of Albedo in Huntsville, sharing his perception on frozen coconut oil, roar of the lion, and the rumble of the Arabian Sea, a tale of urban growth. As usual, before we begin, participants are requested to kindly put their names to log in which you have used while registering. Also, I would like to bring your attention to the feedback form provided during the session and kindly let us know your opinion. And please, if there is any requirement for hello, sir. Hello. Hello, audible.
Audible? Not audible. Yeah.
Hello, sir. Hello.
Yeah. Now okay. Now I can hear.
Hello, sir. Am I audible?
Yeah. Now you are audible.
As usual, before we begin, participants are requested to kindly put their names to log in, which you have used while registering. Also, I would like to bring your attention to the feedback form provided during the session and kindly let us know your opinion. And please don't hesitate to mention if there is any requirements for the certificate of attendance. You can mark up your queries regarding the session in the chat box, which I will read out at the end of the session. Once again, hearty welcome to this 92nd talk of Inter-Society Weekly Webinar Series, IWWS. Now, moving on to the session formally, I invite Noorin Fatima, IEEE EMBS volunteer, to welcome the virtual gathering.
Yeah, Jacob Varghese to do that.
Hello, hope I'm audible enough.
Yeah, Jacob Varghese, go ahead.
A warm and cherished evening to one and all. It's my pleasant duty to bid you all a genial welcome to the 92nd talk of Inter-Society Weekly Webinar Series. It's my privilege and honor to welcome our esteemed guest of honor, Professor Dr. Uday Shankar S. Nair, on behalf of the IWWS, who is currently working as the Associate Professor of Atmospheric and Earth Science at the University of Alabama in Huntsville. We welcome you, sir, to grace this auspicious occasion with your expansive knowledge and experience. Next, I would like to welcome Harindra Lal sir, Chairperson of IWWS, being the catalyst that inspired us to do our best and stand as a pillar of power. With deep sense of appreciation, we welcome you, sir, to this evening. Last but not the least, I wholeheartedly welcome all the organizing societies, delegates from various domains, professional community, and especially the volunteers for today's session, Mr. Gogol, Ms. Manasa Raghu, Ms. Rushda Shaju, and Ms. Sandra Baiju to this wonderful evening. Once again, my cordial welcome to all of you to the 92nd talk of Inter-Society Weekly Webinar Series. Thank you.
Thank you. Now I invite Sandra Baiju to introduce our speaker.
Thank you. Am I audible?
Yes.
Thank you, sir. Today, I feel extremely delighted to introduce our speaker, Professor Uday Shankar S. Nair. Talking about his education, he has done his PhD in Atmospheric Science 2002 in Colorado State University, MS in Meteorology 1991, South Dakota School of Mines and Technology, BTech in Mechanical Engineering 1988, University of Kerala, Trivandrum, India. His article based on PhD dissertation work, published in the October 2001 issue of Science, was selected as one of the 10 most important science papers of year 2001 in the areas of earth science, environment, and ecology by Science News. He has got several awards. A few of them include NASA New Investigator Award 2006, Google Earth Engine Faculty Research Award 2013, NSF Career Award 2014. His primary research interest is in studying land-atmosphere interaction processes using numerical modeling, satellite remote sensing, and field experimentation. He has led multiple international field experiments investigating the impact of land cover change, for example, deforestation, on weather and climate. His other research interests include space and transport of air pollution, boundary layer phenomenon, mountain weather machine learning, and development of low-cost sensor systems. It's my honor and privilege to welcome you, sir. Sir, over to you, sir.
Thank you, Sandra.
Thank you very much for that wonderful welcome. Let me go ahead and share my screen.
Now, let's all synchronize our attention towards the esteemed speaker, Dr. Udeshankar S. Nair. So the platform is all yours.
Thank you. Can you see the screen okay?
Yes.
Okay. If there are any issues, please let me know. Hopefully, internet will behave. I guess I could say good morning and good evening both, because it's morning here. It's a little bit early. This is one of the earliest talks I have given. Let's see. Excuse me for 1 second. Let me move the controls out of the way here. Okay. Again, thank you very much for giving me this opportunity to give this talk. As Sandra mentioned, I got my degree from College of Engineering, Trivandrum, and I'm sure that there are several people in attendance that probably went to school with me. So the title of my talk today is Frozen Coconut Oil, Roar of the Lion, and Rumble of the Arabian Sea, a Tale of Urban Growth. So when we look at the title itself, it seems like I'm stringing together 3 different phenomena that doesn't have much to do with one another. But hopefully, I'm hoping that at the end of the talk, I can connect the seemingly unconnected phenomena all to urban growth. And so the urban growth that I'm going to talk about today is that of Thiruvananthapuram. And before I get started, I would like to first acknowledge some collaborators. So the first person I would like to acknowledge is Chandana Mitra. So Dr. Mitra is associate professor at Auburn University. And then the second person I would like to acknowledge is Suganya Dasgupta. She is working on her PhD with Dr. Mitra. And then there is Chris Phillips, and he is working on his PhD with me. And then I would also like to acknowledge my brothers who are all shown on this picture. The smallest person in the picture is myself, and the other 3 are my older brothers. And so the reason I put their pictures up here is because some of the motivation for this study comes from my visits home frequently. And so when we all get together, we talk about old times and some of the motivation for the material that I talk about today comes from some of those conversations. So a brief outline of my talk. So I want to start with a little bit about the motivation. Why am I doing this work? And so my work relates to multi-decadal analysis of urban growth, and I'm going to focus on Thiruvananthapuram Municipal Corporation. And to do this analysis, I'm going to utilize satellite remote sensing products. And then the next thing that I'm going to do is look at multi-decadal analysis of surface meteorology observations. And the third aspect I would like to talk about is statistical regression modeling. And I do this so that we can isolate effects of urban growth on air temperature from large-scale climate signals. And lastly, I would like to talk a little bit about the study implications and then future work potential and for citizen science efforts specifically. So to talk about the motivation for the study, I have to kind of go back and start from the home that I grew up in. And so this is a picture of the home that I grew up when I was small. So this is located in Vanchiyur, Trivandrum. So the name of the house is Perimandiram. And I would like to point out a few things about this house. So the house is, of course, has a tiled roof, and then there's small parts of it. It's got a tin roof, and then we have windows, and then above the windows you have areas with a little grill. And then if you look at the surrounding regions of the house, we essentially had sand that was covering the surroundings of the house. And if you look in the background, you can see several trees. And I could kind of think about all the trees that was in our yard. So there were probably about a dozen coconut trees. And then we had an Ashoka tree. And then we had a Honna tree that grew in the front of the house. Then there was Jambaka, then Paka tree. So all kinds of trees. And so first when we moved into this house, the tree cover was so dense that it looked pretty dark. And even in the house, the filtering of the light was a little bit curtailed by the canopy that was present around the house. And so if we fast forward, so this is another house. This is my grandmother's house, which is also pretty close by to our house on a couple of streets down from our house. And so again, when you look at this house, it is very similar. The roof is tiles, and you look at the surroundings, you have soil and a lot of trees around. Now, if we fast forward, this is what my house looks like right now. And so there are multiple structures that are there. It's all made of concrete. Windows, when you shut those windows, there is airflow is pretty limited. There are small holes at the top of the buildings that have some airflow. And if you look at the ground, instead of sand, now we have impermeable surface. So there are many changes that you can see going from my old house to the new house. And if you look at my grandmother's house, this is what it looks like now. And as you can see, again, there are major changes. Again, the ground is not exposed anymore. You have impermeable surface, you have concrete structure. And so a lot of changes going on over time on places that I have lived in and my relatives have lived in. And so this is the same for a lot of other people too. So usually when I come home, I usually talk to my brothers about old times. And so we talk about our old home, things that we used to do, all of that. And so when we were having this type of conversation, one of the things that came up was I have to use this map to kind of give some context to this. So again, this is from Google Earth. And so I've zoomed out and our home is located right by the Malabhumi Road right here. And so if you go about 4 kilometers, or straight line, you'll reach the Napier Museum and Zoo. And one of the interesting aspects that we talked about last time I was at home was that we used to be able to hear the lion, which used to look like this when we used to go to the zoo long time back. The lion would roar sometimes in the morning, and we would be able to hear that from our home. Nowadays, the lion has got a much better place to live. It's got its own enclosure, and we don't hear the roar of that lion anymore. And if we go about 2 kilometers to the coast, you will get to Shangumugam Beach. So that's again straight line distance. And when we used to go to the beach, it kind of looked like this. So this is myself, my mom, my brother, grandmother, and cousin. And so if you look around, there is not a whole lot of structures. It looks nice and peaceful. But now, if you go there, this might have changed by now, but you have, again, concrete structure, all of this going on. And again, one of the things that used to happen was sometimes in the evening and maybe sometimes in the morning, we used to be able to hear when the waves thunder onto the beach, the sound that the waves make, we used to be able to hear that from our home. So, so another aspect that we talked from our old memories was what used to happen when it got really cold. There were times when the air got really cold, and a lot of the times my dad used to put newspapers behind these areas where you couldn't really close and it didn't have any glass. So you would put paper so that cold air didn't come into the house and we didn't all get cold. And also another thing that used to happen when air became cold is if you had coconut oil in the house, sometimes that would freeze. And that was something quite interesting when I was a kid. And some of the other changes I could think about is we used to have a lot of dew that you would see when it got cold. And last few times I was home, I noticed that the occurrence of those kind of phenomena has reduced quite a bit. And I talked to my brothers and others, and you know, many of the people said that was probably true. And so my background being in atmospheric science, and one of the things that I study is interaction between land and atmosphere and how that could potentially alter atmosphere. So my thought process kind of went towards, one of the changes that is happening here, as I showed before, our structures, our homes and our yards and everything else around is changing. And also from prior studies, we know that when you have a lot of urbanization, you can generate more heat, and this can potentially affect the state of the atmosphere. And so one of the thoughts that I had was, could there be some connection between all of these observations that we were talking about? Now, this is another zoomed up view from Google Earth. And again, this is for those of you that know the Manjur area. This is the Charakulam Road. This is the Madharbhumi Road. And our house is located on this small side road right about here. And if you notice, there is some area behind our house that has gotten more vegetation. So a lot of the other areas, we're losing trees around the house. And we're getting more concrete on the ground and so on and so forth. But in this particular isolated area behind our house, there has been a growth of vegetation here. And it's quite dense when you look back there. And one of the other things that I noticed over time was when we were growing up, I don't think I've rarely seen any parrots, for example. Same thing with mongoose, and same thing with several other animals. And one of the changes that I noticed when I was traveling back to India every once in a while was every time I looked in this particular area, I would see a new animal or a new bird, and it just looked like a mini nature preserve right behind our house. And so I thought this was really interesting. And then I was also thinking about, why is this happening? Why are all the animals running around and finding this particular spot and just hanging out there? So one of the things that I wanted to look at was, as I mentioned before, land use and land cover change. And especially if you have a lot more urban land cover, then that can alter how much energy, moisture, and momentum or motion is transferred between land surface and atmosphere. So this is a possibility. This can create some changes, and these can affect a lot of these observations that I mentioned here. However, there are other confounding factors. So when you look at changes because of urban, you can also have large-scale variation in climate. And so changes in atmospheric conditions can also result from natural variability of climate, but also from global climate change type of phenomena. So I thought one of the first things that we needed to do, if you want to figure out if all these changes that we're seeing, urbanization is playing a role, then we first need to look at how land cover has changed over Trivandrum or Tiruvandhuram for a long time, over a long period of time. And so what we did was we took NASA moderate resolution imaging spectrometer, or MODIS satellite sensor, to study and see if there has been substantial changes in land cover. So a brief description of what MODIS sensor is. It's essentially what it does is it images the Earth. Approximately, so there are two sensors. One is on a platform called Terra, and the other one is on a platform called Aqua. So what I'm using for this study is on Terra platform, and the difference is that this sensor images at 10:30 during daytime in the morning. And it images in 36 different bands. And this is within a wavelength range of 0.62 to 14.38 micrometers. So what does this mean? So this is essentially a plot of reflectance. So reflectance is essentially you have so in the visible wavelength, if you have energy from sun in that particular wavelength band, and then part of it gets reflected back to the satellite sensor that is imaging. And so the amount of energy that is falling on that point and the proportion of that gets reflected back, so that is the reflectance. And so at each wavelength of light, that reflectance could be different. And depending upon what kind of substance that you have at the particular point that the satellite is observing, you can have different types of different values of reflectance. So there are some examples here. For example, the blue line is green vegetation. Then the dashed line that is shown here is corresponding to dry vegetation. And then you have orange line here that corresponds to when you have just bare soil. And so there are spectrum for a lot of other type of land cover material that when you observe what you see. So essentially you have patterns of spectral reflectance that are different for depending upon the land cover. And so we can utilize this information. So when you sample the reflectance at 30 different different wavelength bands, you can use that information to kind of distinguish, for example, between vegetation and bare soil, or maybe concrete and water, and so on and so forth. So essentially using this information, you can try to assign at each point that the satellite sensor is looking at what type of vegetation or if there is built structure there. And one other quantification that you can do with this satellite data is you can use the difference in reflectance between, for example, between two wavelengths to figure out the health of the vegetation or the greenness of the vegetation. So you can come up with an index called NDVI, whose value go from 0 to 1. So if it is 0, that indicates that you have bare soil. And if you have closer to 1 that you get, the more lush green vegetation and high density of vegetation cover that you have. And lastly, in the bands that observe in the infrared, you can use that information to figure out what is the temperature of the land surface. So these are some pieces of information that you can get from the MODIS satellite sensors. So, one of the things that we did first was to to go and use the satellite data to kind of do a survey of how has land cover changed over Trivandrum, and also to look at the changes in green vegetation cover. So for my study area, I'm going to focus on the Trivandrum Municipal Corporation boundaries. So from here on, I'm going to call that TMC. So in this graph, essentially this figure is showing the southern part of India and Sri Lanka here. And the area that is shown in more detail here is from this region shown by this red box right here. And so if you plot the boundaries of Tiruvandhuram Municipal Corporation or TMC, that is given by this red line here. And before going and looking at changes that are happening here, as far as land is concerned, we decided to take a look at how people have been changing, the amount of people have been changing in this region. So that is shown in this graph B here. So in this graph on the x-axis, I have years going from 1955 to 2030. And on the y-axis, I have population count. So this is in thousands. So you got to multiply that by 1,000 to get the number. And so this is from the UN. So UN has put together population data for different cities. And also it has made projections of how population would change over the next 50 years or 100 years and timescales. And so as you can see, from 1955 to 1985, or the growth rate was pretty small compared to what comes after. And so one of the biggest changes that you can see in this region is around the year 2000, when there is a large rate of change in the increase of people per year. And the dot here is actually the latest 2011 census count for the city. So this is for the actual city itself, but this curve here is for the urban agglomeration. So that includes city and the surrounding areas. So this kind of gives a good idea of demographic changes that is happening in this region. So next, what I want to do is I want to take a look at what we found out regarding the changes that has been happening in the Trivandrum Municipal Corporation region. So this shows comparison between the different types of land cover that existed in this region in 2001. And this panel on the right-hand side shows how that has changed by year 2019. And so just to give a quick explanation of the different colors here. So MODIS uses land cover classification that can be applied globally. So some of the classes that are shown here may not, the local interpretation may be slightly different than these classes are. So the each color I have given 2-letter designations here, and so what those designations stand for is given on the right-hand side here. I want to mainly focus on urban. So there is one class called urban, or UB. So if you go to the letter UB, you see the color gray here. So whatever is you see in gray here is the urban land cover in 2001. And by 2019, as you can see, the urban area over within Trivandrum Municipal Corporation has increased quite a bit, and it is actually almost extending to the eastern boundary, yeah. And also it has expanded in the north and south direction. And if you look along the coastal region, there is significant increases in urbanization. Now, I want to point out why we are focusing on the 2000 to 2019 period. The reason for that is because two reasons. One is that is when the biggest urban growth in this region occurred. The other reason is because MODIS satellite observations are mainly available for these 2 decades. And so before I move from this figure, I want to point out a couple other things. So if you look here, there is a dark green color, which is evergreen broadleaf or forested type vegetation. And there is 2 patches of that was there in 2001. And in 2019, most of those, both of those patches are gone. And some of the other changes are associated with wetlands, which is given by blue color. So there's some, it's a little bit hard to see here, but there are some changes in the wetland. So this kind of gives the pattern of change, but it doesn't give you numbers. So how much now we need to quantify how much change that has happened over this time. So we can do that by creating a land cover use change matrix. And so what this is showing is along this column here, you have in square kilometers, the amount of area each of these particular land cover classes occupied in 2001. And along this column, what it's showing is the aerial coverage for the same classes in 2019. So there's quite a bit of information here, and I don't want to go through all of that. I want to mainly focus on the urban and built up, which is essentially the concrete structures and housing development and all of that. And so urban and built up in 2001 occupied about 46 square kilometers. And by 2019, that has increased to about 73.88 square kilometers. And now if you need to figure out where did all those urban area come from, you can actually go across this column, this row here, and it will show you which of the other classes has been converted to urban and built up. And so what we find is that the category called cropland and natural vegetation mosaics, so that is 18.50 square kilometers, so that has been converted to urban. So that is one of the major sources for urban land cover change. Now, we can also look at the temporal pattern of urban growth. So we can look at it in 2 ways. One is I can just plot along the x-axis, the years, and then on the y-axis, I can just spot how much urban area there is for each year. And so if I do that, I get the following curve. And again, if you look at the shape of this curve, this matches the population curve very well, the shape of it. So this is definitely driven by changes in population. We can also quantify how much these changes are. So I can do that by fitting a slope to this line here and here. And so if I fit a line here, the slope of that line is 0.53 kilometers square per year. And so during the first 10 years of the period that we are analyzing, urban growth happened at about 0.53 square kilometers. It increased by about 53 square kilometers. Now, we can also put an average number for the second half of this period, and that number is about 2.54 kilometers per year. So this is almost 5 times of the growth rate here. And you can also quantify growth rate for each year. So what we are doing here is we are expressing how much urban area changes as a percentage of the total area of Trivandrum Municipal Corporation. So, when it really started growing, at the peak, it was actually doing about 1.93 percentage area was being changed of the total municipal corporation area. So there are some interesting patterns here. So there's the sharp increase here, then there's a decrease, then we reach the peak here, and then we dropped again. And I cannot really explain why these patterns are there, but I would be really interested in getting input from anybody that has studied this from a demographic perspective or from economic. So this is socioeconomic drivers, and it would be really interesting to understand what is driving those changes. So, so the next thing that we did was we went ahead and looked at, okay, now we know that land cover has changed, but now what we want to understand is what are the effects of those land cover change. And so these plots are essentially showing what those changes are. And so what we are doing here is we are averaging characteristics spatially for the time period of 2000 to 2009. And on these panels, I'm showing averages for the time period 2010 to 2019. So these are 10-year averages of whatever characteristics that we are looking here. And so whatever changes that you're seeing here, it is a very strong signal. So it is not a fluke. It's showing up in a 10-year average. So that's how I would like you to look at these signals, because they are really, really strong. So now let me explain what we're looking at here. So the first panel, what we're looking at is land surface temperature. So this is the satellite during the early morning time, so 10:30 roughly, looking at the surface of the earth and figuring out what is the land temperature at a particular point. And so this is at 1 kilometer spatial resolution. And so what you see here is a kind of a small hotspot spread out like this. The maximum temperatures are about 306, 307 K, somewhere around there. But look at the change after the urban growth has happened. So you can see that the hotspot has just increased all the way to the eastern border, and the total area of that hotspot has become quite large. Maximum temperatures that you see, especially in this spot right here, is about 308 K. The bottom two plots actually show the land surface temperature at nighttime. And again, if you look, you see, excuse me.
The light on top.
You see this pattern, similar patterns, and you can see even at nighttime, there is this really strong hotspot that persists. And I want to take a second to point out these two markers here. These are meteorological stations that collect surface weather observations. So I'm going to show some data from these particular stations in a minute. And these two panels here are essentially showing NDVI. As I mentioned before, the way we interpret this NDVI is that as the value go from 0 to 1, your amount of green vegetation is increasing. So, so higher the values, more lush vegetation and more dense cover of vegetation that you have. And so again, 2000 to 2009, if you take the average, what you see is in the urban area. So if you remember from the previous figure, the urban area is mostly located here in 2009 period. And now if you look, that low values of vegetation, NDVI values have expanded, and now it's occupying a much larger area. It's doing that along the coast, it's doing that along the heart of the city. And if you look at the very heart of the city, it has become pretty bare. So if you look at the values here, it's pretty close to 0.2. 0.2 is getting pretty close to having no vegetation. And if you look at other regions between these two time periods, there is quite a bit of loss of vegetation in the urban core. We can also look at time series of land surface temperature. So that's what's being shown here. So the top plot is daytime land surface temperature, and the bottom plot is nighttime land surface temperature. Now you can see that there is seasonal changes, and so this is monthly average values. And so there are seasonal changes. So values are going up and down, but you can see a trend here of this oscillating pattern is actually kind of trending with an increase. And so I can actually do analysis, time series analysis, where I remove the seasonality. So if I remove the seasonality, the remaining trend is shown in this figure right here. And this is for nighttime. And I can look at the trends using statistical methods, and I can confirm that these are statistically significant trends in land surface temperature. So from 2000 to 2020, essentially we have a 1 degree change in land surface temperature. This is averaged over all of Trivandrum Municipal Corporation. So this is not just for a point. This is average for the whole corporation region. And so individual points, the temperature changes could be even much larger. So I also looked at albedo. Again, this is 2000 to 2009, 2010 to 2019. So albedo essentially denotes when sunlight comes in, how much of it gets reflected back away from the surface. And so one of the changes that you see is there is a large change in albedo associated. So there is an increase in albedo, or urbanization is causing more sunlight to be reflected out. And we can also look at the parameter called emissivity. And emissivity is essentially how efficiently does the surface radiate heat out. And so black body is the most ideal. And so emissivity shows how close to black body is the surface radiating. So as the values become smaller and smaller, that means that surface is less efficient at radiating energy. And so what happens is, if you look at the city, you will find that there is a much smaller emissivity over the urban core. And what this implies is that since it cannot radiate that energy very effectively, the surface temperature is going to increase. So for example, some of the value differences here between the city and the surroundings, that could account for about 1.5 degrees just from that change in emissivity. So what about, so we know that land surface is changing, but what about the air temperature? So again, we can look at what I did was the station that I showed you earlier this particular location. So I took the data for that station. So in here, I'm showing temperature. There's a lot of information here, but I will try to kind of guide you through so that we can get the correct point out. So what I'm showing here in this panel is maximum temperature. This is minimum temperature, and this is average temperature. And so, and this is monthly average temperature, and this is for a long time period, starting from 1974 to 2019. And so this is what I'm doing here in this panel called trend, is I am removing the seasonality, and whatever is left after the seasonality is shown in this figure here. And so this is what the temperature after you remove the seasonality is doing. So maximum temperature in 1974 on average used to be about 29 or so, and or 29 and a half or something like that. And it's shown a steady increase all the way to about 32 degrees now. For the minimum, again, we're starting from about 24, and slowly the minimum temperatures are also increasing. And if you take the average, of course, that will also show an increase. Now, I did this for dew point, but I'm not showing that here. Dew point essentially indicates water vapor, and that also shows an increase. But another interesting aspect that I found when I did this kind of analysis for wind speed. So I'm showing again maximum wind speed, minimum wind speed, and average wind speed. Note that one of the things that has happened is wind speeds maximum used to be about 4 meters per second. Then all of a sudden, somewhere around 1985, 86, somewhere around that period, it started going down. And then all of a sudden, we have a sharp decrease in wind speed that is measured in the city. And this is a very consistent pattern, and it shows for maximum and minimum winds too. So there are two things that we can conclude from here. There are some significant changes that are happening, but it has also happened over a very long time period. So we cannot attribute all of this to urbanization. So then the question is, how do we figure out what urbanization is doing? And so how do we isolate the urban effects? And so one of the ways that we can do that is by going and taking some information from ocean area. So the air coming into Trivandrum is actually coming from ocean area. And so the climate of these two regions are going to be very similar. But at the same time, the air here is not being affected by urbanization. So if we construct a statistical model that can take information from this region and predict the temperatures in over Trivandrum, then we can use that information to kind of parse out what is coming from large scale and what is coming from urbanization. So I used NASA reanalysis time series data. So it's from a model that is available for a long time period for doing this. And so what I did was, so this is the temperature trend after seasonality is removed. That's the observed trend. So when I use my statistical model, here's the prediction that comes from that statistical model. As you can see, it is very close to actual observed prediction, but there are some differences. So when you take the differences, what is left over, you can attribute to changes that are from other causes. And so when I do this analysis, this is the temperature trend that you get that is left over after I account for climate change. And so this is about minus 0.3 to 0.3. So this is about 0.6 degrees over this time period. But if you look at minimum temperature, we don't see such a trend. So a lot of the changes in minimum temperature cannot be really attributed to urbanization, except for, if you look, there seems to be a little bit of a trend after 2010 when the population started going up. And the other thing that I did was actually go in and compare. There is another station here. So we can compare these two stations. And if you look at this station, the urbanization around this station happened at a later stage. So that's another way we can look at what the effects of urbanization are. And if you look here, what we're doing is we're comparing wind speeds for the period 2000 to 2009 between the coastal station and the city station. And what you find is essentially in 2000 and 2009 period, these two stations showed very different behavior. But when urbanization started happening along the coast, the behavior of these two stations become somewhat similar. So essentially there is a shift in when the maximum temperature happens. There is a decrease in wind speed. There is shift in wind direction. There are a lot of other changes that are happening. So this is again another signal of urbanization. So it's getting pretty close to the end of my time, so I better connect up some of the ideas here. So what does this all have to do with coconut oil, frozen coconut oil, and other aspects that I was talking about? So we can understand that by, if you look at the minimum temperature curve that I showed earlier for Trivandrum. Now, if you look at coconut oil, it freezes at 25 degrees. Now, this is the trend of minimum temperature, okay? So what is happening is the difference, the minimum temperature in the old days used to be much cooler than the temperature that you required for freezing. But nowadays, we are getting more and more closer to that freezing point. So essentially, it is getting too warm. And you can see that even better if you look at the raw data for minimum temperature for every day. And what you see earlier in the old days is there is a lot of days where temperature becomes much smaller than 20. And so we used to have a lot more cooler days, but look at what happens when you have the urbanization. A lot of those spikes have pretty much gone away. But you also have to add the other effect, which is there is difference in temperature between indoors and outdoors. Here's one example from a study. So there is about 5 degrees difference. You can have up to 5 degrees difference, depending upon what your house is built of, what your windows are like, so on and so forth. So as I mentioned, a lot of our houses, it's being built of concrete, there's a lot less ventilation, so on and so forth. And so combined with this reduction in minimum temperature and this differential you get from having a concrete house could explain why we are seeing this. Now, what about the rumble of the ocean and roar of the lion? Why cannot we hear that anymore? And so one of the ways that we can explain that is by using temperature inversions. So temperature inversions is when you go up in the atmosphere, if at some location, if the temperature increases with height, that is called temperature inversion. And what happens when you have this kind of inversions is that studies have found that it can actually channel sound. So it can create a duct that keeps sound low to the ground, and then it doesn't allow the sound to spread in a spherical fashion. So people have done studies where they have looked at elephants communicating in this kind of environment, and they have actually shown that the attenuation of the sound over distance decreases when you have this kind of inversion. So one of the things that happens when you have urban heat is that these kind of inversions break up more often. So one of the reasons why we don't hear sound propagation that like we used to when we were kids is probably because of this heating and change in structure of this inversion. But it is also possible that there is a lot more obstruction in the way, there's a lot more sound pollution. But this could be one of the explanations. But this needs to be looked at. Habitat destruction. is another aspect. So when we looked at the vegetation cover using satellite data, it suggests widespread destruction of habitat. And so this means that this will increase migration to any available green space. Animals needs to be somewhere. And so that's why they're all hanging out right behind a small plot of land that's got a bunch of trees behind my house. Another aspect is, the changes in microclimate that is happening because of urbanization. It can affect species like mosquitoes, things like that. So this is another effect that can happen. So one other point I want to make is that Tirunelveli, air from Tirunelveli flows up Western Ghats, and when it does, it always forms rain and clouds and rain. And so when you have an urban area, changing the air that is consistently being forced upwards by terrain, essentially Western Ghat, that can actually change the amount of rain that falls at upper elevation. So this is from one of my previous studies in South America that shows similar effect from a city that is located similar to Trivandrum by terrain. Couple of things that I want to do in the future is to use numerical model to further study this urban growth of Tirunelveli and how that is affecting the environment. So there's a need for high resolution land cover maps. So this is a great opportunity for citizen science to get engaged. And the other study that can be done that could be very useful is in understanding the temperature differential between inside and outside for different types of houses. So starting from old thatch roof houses to new concrete houses and how the windows are built, you could get a lot of information from that. So this is another way citizen scientists can participate. This would be a great opportunity for engineers because this needs building sensors, programming, all kinds of fun stuff. So in conclusion, the study found a really strong signal of urban impact for a municipal corporation of Tirunelveli. The urban growth can account for up to about 0.68 temperature change over the last 2 decades. So large scale climate seems to have changed about a couple of degrees or so, but over a longer time period. So this number is not insignificant. Impact on nighttime minimum is not as clear, but there seems to be a signal, at least for the last 10 years, but that needs to be cleaned up a little bit. And there are also indication that urbanization may be impacting sea breeze because there are large changes in wind speed, wind direction, so on and so forth. So one other point I want to make is this: I conducted all of this research using Google Colab, and it utilized data that is freely available in the cloud. So the point of this is that I can send all of this information or analysis pipeline over email to somebody, and they could replicate whatever I did here. Every figure, every analysis that I did, they can easily reproduce. So the point here is that citizen scientists or any interested parties can take the methodologies that I've created here and apply it and adapt it for other cities. So I think I've run over my time. Sorry about that. And I will stop right there. Thank you. I'll be glad to answer any questions.
Thank you, sir. That was really a great interactive session. Now, the participants are kindly requested to put their queries in the chat box.
Would is someone going to read the questions, or do I need to?
Manasa, you may please read the questions. Manasa,
Yes, sir.
you may please read the questions. Yeah. Now you are audible. Come on. You are unmuted. Now speak out.
So the biggest mass destruction is in the Valley Akkulam wetlands, which is the largest groundwater recharge in TMC.
ശ്യാമിന് ഇടപാട് ചെയ്ത സംഗതി കൊണ്ടുവരും സമാധാനപ്പെടും.
Is that a comment or was that a question? I didn't get that.
It's a comment. If you have something to add to that, or otherwise you can leave it.
Oh, okay. Yeah, I haven't looked at the that area directly. So one of the issues with the data that I'm using is that it's 1 kilometer spacing. So to look at that information, we'll need a little bit more finer resolution satellite data. And so to do that, we need to collect ground truth data. So this is where, if you have interest, I'll be glad to work with you. We can do that mapping and look at what those changes are. But I will need some information to actually train the satellite data and classification for satellite data and so on. Thank you. I did not know that. So there was another question about what is the suggestion for improving the situation. I think the easiest thing that can be done is reduce the amount of impervious surface. So as I showed the houses, I showed the transition from sand to kind of paved surface. So I think much of the heat is actually coming from a lot of the sunlight going into heating the surface rather than in the old days, it used to go into heating and evaporating water. So one of the biggest changes that can be done is if you can avoid at least paving your yard, that could help a lot. And there is also construction materials that people have been trying to come up with that would have permeable features. So that might be another option too. So there was another question about Trivandrum used to be a lot more comfortable, but now it is not very comfortable to stay. Said man-made problems is the root cause. Yeah, I would say that the type of constructions that we're doing does have an effect. But it is a really hard problem to fix because a lot of the time, we have our short-term goals are more important than long-term good. So I'm not sure what we can do about that. So someone else said they were in Kanaganagar and used to hear the roar of the lion. So I'm glad to hear that other people have noticed that too. One other question was somewhere you took the difference of temperatures between the two time series and concluded that delta T is due to some other reason. Can you explain your analysis? So what I'm trying to do there is the time series over the ocean is not affected by urban surfaces, but it is affected by large scale climate change. So the signal of change from large scale climate is present in the time series over the ocean. So, so when you create a regression model, what it does is it will try to predict the changes that are happening because of the large scale climate that is affecting the city, but not the changes that are occurring because of other effects. So what it does is it creates a prediction that is taken into account only large scale climate change effects. So when you take the difference of that predicted temperature and observe temperature over Trivandrum, whatever is left over potentially has to be due to the urban effect. So that is the idea behind that analysis. But it's really a statistical technique, and it has its own issues. And so one other way to kind of prove that would be using numerical models, but it takes a lot of computational effort and a lot of time to get that done. Someone else said, Indulega said, I missed the beginning of the talk. Was rainfall data presented? Any change? I looked at rainfall a little, and my first impression was the changes. I didn't see, there are some differences, but I don't think it was statistically significant, but I need to go back and look at that again. Thank you. Thomas said, would you be kind enough to share your email and contact info? I can do that. What will be I can share that with Harindra Law. Would that work? Someone Indulega said, give some references to your work. So this is actually a publication that I'm putting together. So it is going to be submitted in the next couple of weeks. So as soon as that goes through the review process, I'll be glad to give you that information.
If you can send to me, I shall share with the participants, if it is okay.
What was that?
If you can send me this information required, I shall share with the other persons if it is required.
Okay. Okay.
Manasa, we are going to the next program. Hello. I invite Google for the vote of thanks. Google.
Thank you, sir. Yes, sir. I'm audible.
Yes.
So, good evening, everyone. Thank you all for attending the 92nd talk of Indus Society weekly webinar series. First of all, I would like to thank Mr. Harindra sir for organizer of Indus Society weekly webinar series for successfully conducting the previous 91 talks. Next, I would like to express my gratitude to the speaker Professor Udaya Shankar S, for delivering such a wonderful and informative session, and also for answering the queries regarding the same. Thank you, sir. And I would like to thank all the organizations who are involved in this initiative and supporting us continuously. I would also like to thank the Zoom master Rashda, the MC for the day Mansa Raghu, the welcome speech by Jacob Varghese, and introduction by Sandra Baitu. Thank you, team, for the joint effort At last, I would like to thank all the attendees who attended this meeting. Over to you, Mansa.
Thank you, Gogol. As we have come to an end of the session successfully, I would like to announce the next session in our Inter-Society weekly webinar series, that is the 93rd talk of our weekly webinar series on 19th January 2022 from 6 to 7:30 p.m. Attendees kindly take a note on that and stay tuned for the session. Hope to see you all on next Wednesday. On behalf of IWWS team, thank you from the bottom of our heart for joining with us today on this 90-second talk. Goodbye, and this is Manasa signing off.
Next week's program is on condition monitoring, health assessment of power transformers by Raghu Kumar, former head of transmission, Qatar General Electricity and Water Corporation. Next week, I request all of you to continue your patronage and support this program. Uday Shankar, thank you very much.
Yeah, thank you for the opportunity to talk. I enjoyed that.
For coming over here for the untimely time for you. It's early morning, perhaps. Yeah.
That's okay.
Yeah. Once again, I thank you. We will see you sooner. Thank you very much once again for all the participants. See you next week.
Thank you.
Okay. Rashda, please close it.
Okay, sir.